Well, hello guys, here Mr. G with another video. This time we're going to be solving a question for the grade 12. This one is question 4, or it was question 4 done in September 2023 in the Western Cape province. This one is about momentum, but before we answer the question, don't forget to subscribe for the channel so you can get all the notification and videos I post on regular basis. I will leave the question in the description below so you can answer before watching the video. The question says, a boy on a skateboard is initially at rest. It means that the initial velocity of this boy is equal to 0 meters per second. It's at rest. On a smooth horizontal pavement, it means the frictional force is equal to 0. He throws a heavy ball of mass 5 kg horizontally to the left. So the mass of this ball is equal to 5 kilograms. Okay? To the left. This is shown there in the picture at the speed of 3 meters per second. Immediately after the ball is thrown, the boy-skateboard combination moves at a speed of 0.2 meters per second. So the final speed, they don't give you the direction, is 0.2 meters per second. Okay? Ignore the effect of friction. Question 4.1, state the principle of conservation of linear momentum in words. So you have to state the principle in words, and it's quite simple. Alright, so what do you have to say here? The total linear momentum of a closed or isolated system remains constant. And if you say that, guys, you get 2 very easy marks. The next question says the total mass of the skateboard is 2.5 kilograms. So the mass of the skateboard is 2.5 kilograms. Alright, and that is just for the skateboard. The mass is equal to 2.5 kilograms. Calculate the mass of the boy. Very good, because so far I didn't see this question very often. So let's calculate the mass of the boy. Now, to answer this question, we are going to apply the law of conservation of momentum. So to start, we're going to say that the total linear momentum, the initial total linear momentum, will be equal to the final total linear momentum. Okay, and the two objects here of interest are the ball, that is important, and the boy with the skateboard together. Okay, those are the two objects of interest here. This is our system. So initially we are going to have that is the initial momentum of the ball plus the initial momentum of the boy and skateboard. Let's write it with a capital. Okay, and this one, let's do it ball, let's do it with a small b. This one is for ball and the other one is for boy. Is equal to the final momentum of the ball plus the final momentum of the boy. Boy, when I mean boy, I refer to boy with a skateboard. Okay? Now, if you remember, momentum, definition of momentum is equal to the product of mass and velocity of the object. Okay, this is the definition of momentum, and we are going to substitute in each of them. So the initial momentum of the ball will be the product of mass of the ball multiplied by the initial velocity of the ball, plus the initial momentum of the boy will be the mass of the boy. Remember, it's boy and skateboard multiplied by the initial velocity of the boy is equal to mass of the ball, final velocity of the ball, plus well, I didn't write here v, let's fix that one, final velocity of the ball plus mass of the boy, final velocity of the boy. This is the law, and the good news is that you will get the first mark for any of those. Any of those will carry 1 mark. Okay, now let's go back to the picture. What is the thing here? They speak about this speed, but they didn't speak direction. Now, if he thrown the ball to the right, it means that he's going to move to the left. So this one is left. Okay? Okay, and before we carry on, we are going to write a direction taken as positive. So in this case, I think we can say right is positive. Okay, so let's write right is positive here and do all the substitution. Well, there we go. So the mass of the ball is 5 and the initial velocity of the ball is 0, plus the mass of the boy is Remember, the mass of the boy, it means, and let's maybe write it down somewhere here. This mass here means mass of the boy actually plus 2,5, which is the skateboard. Okay, that is MB. So let's substitute it in that way. So here is going to be M plus 2,5 multiplied by the initial velocity of the boy, which is 0. Alright, now if you notice it's 0, guys, you don't have to substitute. You can already write 0 for everything here because all that is going to be 0. Now here is going to be 5, and the initial velocity of the ball is to the left and is 3 meters per second to the left. Therefore is -3 plus this one is M plus 2,5 multiplied by the final velocity of the boy, or after he thrown the ball, which is 0,2. So this one is multiplied by 0,2, and the rest is mathematics. This one is going to be 0, and this one is going to be 0. So we have that 0 is equal to -15 plus, and now here you have to solve this one. You get 0,2 M plus 0,5, and when you rearrange this one, it's just simple math. You get that is 15 minus 0,5 equal to 0,2 M, and then M is equal to 14,5 divided by 0,2, and it will give you that the mass of the boy is 72,5 kilograms. That is the answer for this specific question. Now, if you do that, the first mark is for the formula, for the law. The second mark is for this 0, guys, be careful with that one. And then the third mark is for this part there, with a final mark with the answer. And it's quite simple to get those marks. Question 4.3, calculate the magnitude of the impulse that the boy-skateboard combination experience when the parcel is thrown. Now, what we need to know here for this specific question? We need to know that momentum or impulse. I'm going to write impulse like this, but impulse is also the symbol J, internationally used. Okay, it's going to be equal to the change in momentum. We are speaking about the boy-skateboard system, because that is the question. Calculate the magnitude of the impulse of the boy-skateboard system. Now, change in momentum is final momentum minus initial momentum. And when you solve that one, I don't want to take too long here, is equal to the product of mass multiplied by the final velocity of that system we're speaking about minus the initial one. Alright, for this question, we're also going to take right as positive. So let's maybe write it down there. Yeah. Write positive. Okay, and then we substitute. Now be careful here because we need the direction and the total mass. So here mass is what we calculate the mass of the boy. So it's 72,5 plus 0,2. What is the mass of the keyboard? 2,5. So it is going to be 72,5 plus 2,5, which is 75. 75 is the mass of the boy-skateboard. This one is 72,5 plus 2,5. That is equal to 75 kilograms, guys. That is important, okay? Multiplied by the final velocity is given to us. It was 0,2 to the right, so it's positive 0,2 minus initial was 0. And this one was equal to 15 Newton second. That is the answer here. If you get that answer, then you will get 1 mark for the formula, 1 mark for the formula is either one of those. 1 mark for the substitution, 1 mark for the final answer. 3 very easy marks there. Okay, now question 4.4. Without any further calculation, write down the change in momentum experienced by the ball while it was thrown. Now, the momentum of the ball is going to be equal to the momentum of the boy skateboard, but in opposite direction. So in other words, the change in momentum here will be equal to 15 newtons seconds, but to the left. And this is the answer to the question. That is the final answer. If you say that, you will get 2 marks. 1 mark for the magnitude, 1 mark for the direction. Guys, this is this question in terms of momentum. I hope it helped. Okay, so good luck, thumb up, subscribe for the channel. I'll see you next time. Mr. G here.